In Python, a decorator is a tool that allows you to extend or replace the functionality of a function without rewriting it. Take, for example, a function that returns a numeric average of a list of numbers. If we run this code, we get an average of 83.4. Suppose now that we want to modify this function using a decorator to round our averages up to the nearest multiple of 5. We can define a decorator as a function that takes a function for us to modify. This decorator will then return a new function called a wrapper. Our wrapper will call the original function and modify its value appropriately. Then we can redefine our average function as this created wrapper function. If we uncomment this and run it, you can see it works as expected. If we come into our second example, you can see an improved version of the same program. Rather than reassigning a function, we can use the @ symbol in Python to decorate a function at its original definition. Also notice that I've imported the wraps decorator from functools and I've applied it to our wrapper. This will modify the metadata of our wrapper and make Python think it is the same as our original function, which is why we pass the wraps decorator func as an argument. If we run this, we get the same result from before. Now, let's look at a generic decorator that can take arguments. This is called a decorator factory, since it constructs decorators. We can supply it any arguments for how our decorator should work, which I've called dargs and dquargs. The factory then uses those arguments to construct a decorator as we've seen before. The decorator solely takes the function as a parameter. It then will return a wrapper, which wraps func, and takes all arguments func can take. We then call func in our wrapper, modify the value, and return it as normal. If you look below, we can then call our decorator factory as such and provide arguments right in our @ statement. Now, let's look at a more concrete example of a decorator factory. Suppose, once again, we want to average a list of numbers, but perhaps we want to choose what kind of average, be it mean, median, or mode. When we decorate our function, we can supply it this argument and then modify the functionality of our wrapper. If we change the argument that we provide, the output will change. Note that these decorators don't make that much practical sense, but they're simply designed to give you an idea of how they work internally. Choosing when to use a decorator is as important as understanding how they work. Let's look at some useful built-in decorators that you will commonly use in Python. I've created a simple line char class that keeps track of the number of objects. Each object itself stores a string and an index for the string. We can then use the property decorator on a method to allow us to access it as if it were a property and not a method, as you can see down here. This is called a getter. Below, we can use the mychar.setter decorator to define a setter. If we reassign the property, this method will be called. There is also the class method decorator that allows us to define methods that belong to our class rather than to an individual object. These are like static methods in other languages. We may also combine decorators, but be warned, this can easily break. You need to ensure that your decorators are compatible and are placed in the correct order. If we run this, you see our getter property works. Then we can call our setter by reassigning mychar, and you see that works as expected as well. Lastly, both our getCount class method and myCount class property work. Note that class methods must be related to the class they are in. You can use the static method decorator to create a class method with no relation to your class if you feel the need to do so. In the ABC package, there is an abstract method decorator that allows you to create well-defined abstract classes in Python. You can also use this with decorators we've already discussed, but once again, their order matters. In previous versions of Python, there used to be single combined decorators for things like this, but these have been deprecated in favor of decorator stacking. If you're curious, you should also look into the cached property decorator in functools as it has a lot of utility. I hope this video has been useful for you without wasting your time. If you have any questions, feel free to ask them in the comments. See ya!